Hello, and this video is going to be on lesson 6-1, finding inverse functions. Learning targets are to find the inverse of a function and to write the inverse using proper notation. This begins on page 89. Okay, so it begins with a scenario. Green's Grass Guaranteed charges businesses a flat fee of $30 plus $80 per acre for lawn mowing. For residential customers who may have a more limited budget, Jim Green needs to determine the size of the yard he could mow for a particular weekly fee. Number 1. The cost function f is c equals f of a. It can be written c equals 30 plus 80a, where c is the cost to mow 8 acres. Use the function to determine what part of an acre Jim could mow for each weekly fee. Okay. So first of all, we need to take a look at this function here. And what does C represent? Well, C represents the cost, and A represents the acres. And so if it's giving you $60, where am I going to plug those $60 in? I'm going to plug it in for C. So we have 60 is equal to 30 plus 80A. And what are we solving for here? We're solving for acres. So just using basic algebra skills, let's just do the first example. In order to solve for acres, first thing I need to do is subtract 30 from both sides. And what that gives me is 30 is equal to 80a. Next thing I need to do here is divide by both sides by 80. And that gives me that the acres is going to be 30 over 80, which simplifies to 3 over 8. And so, if the cost is $60, how many acres did I mow? 3/8 of an acre. And I prefer you to keep it as a fraction. But we can find out what decimal that is if you wanted to know. 3 divided by 8. That's 0.3775 acres, which costs $60. Alright, and that's how you find out the rest. B and C. To make a profit and still charge a fair price, Jim needs a function for calculating the maximum acreage that he can mow based on the amount of money a customer is willing to spend. What are the units of the domain and range of the cost function in item 1? Well, that's fairly easy. C equals 30 plus 80a. First of all, you need to identify what is your input. What am I domain range cost function? So what is the purpose of this function? It's to determine what the cost is going to be. So it is my cost function. This is my output. Now another name, what the output represents when you put them together is that it represents what the range is. And therefore, since we're talking about cost, the units are going to be dollars. And therefore my input is how many acres is it going to take. Another name for input is, well, when you take all your inputs and then put them together, they're going to form the domain. And in this case, the units of the domain are acres. So this is just as simple as finding what the input of your function is and what your output is in order to find the domain and range. Number 3. Solve the function equation from item 1 for a in terms of c. Now don't let the wording throw you off here. What is it asking us to do? Solve the function equation for a. So you're solving for a in terms of c. Well, that basically tells you what the other variable is. So you want to solve for a. And isn't that what we basically did here? We solved for a, but instead of plugging in a number for c, you're going to leave it as the variable c. So what we need to do is we need to go ahead and begin solving for a. What is the very first thing that we did here? Well, we subtracted 30 from both sides. And so what we get is we get c minus 30 is equal to 80a. And after we subtracted 30, the next thing that we did is we divided by 80. And that's what we're going to do. Divide 80 by 80 on both sides. So we need to divide this whole expression by 80, not just c over 80 or negative 30 over 80, the whole thing. And what we get in the end is a is equal to c minus 30 divided by 80. Okay. Alright. So what we're going to do now is we have two functions. We began with the function c equals 30 plus 80a. And from that function, by just solving for a in terms of c, we get this function right here. A is equal to c minus 30 divided by 80. And so Jim can actually use this function here to plug in the costs. A equals c minus 30 divided by 80. What Jim can do is he can just plug in the cost now in for c, and that is going to give him how many acres is going to be the answer. So we can do that again with 60 here, $60. So I'm going to take my function a is equal to 60 minus 30 divided by 80. Is that going to give me 3/8 again? Well, let's find out. 60 minus 30 is 30. When you divide it by 80, it again gives you 3/8. So yeah, it worked. It worked just fine. Now, what we want to do is, instead of calling it, we're going to call these functions different names. What we want to do, the first function that we had, 30 plus 80, a, we're just going to call it f of x. F of x equals 30 plus 80x. And now, my other function, g of x, equals x minus 30 divided by 80. So we just basically have the same functions, except we're calling them different names. Now, what we want to do is we want to find the composition of both of these functions. And let me just go ahead and tell you that because we found this function by solving for a from this function right here, these functions are inverses. inverses. And we're going to look at some properties of inverse functions. And so, again, these functions are inverses. And let's take a look at what happens when we take the composition of the functions that are inverses of each other. So first thing we want to do here is find f of g of x. First of all, what is g of x equal to? Well, g of x is equal to x minus 30 divided by 80. And so what we want to find out really is f of x minus 30 divided by 80. And how am I going to do that? Well, I'm going to take my inner function. Well, this is my inner function here. But I want to take this expression, and it's going to be replacing x, specifically right there. And so what is that going to look like? It's going to look like this. 30 plus 80. And instead of writing x, x is going to be replaced with x minus 30 divided by 80. That's it. That is how you compose both functions. And now we just need to simplify this. So we're going to, what we need to do here now, some of you may be tempted to distribute the 80, but let's not complicate things for ourselves. Let's keep it simple. 80, this 80 here and this 80 on the bottom, they're going to simplify to just 1. And so what we get here is 30, and since there's nothing outside the parentheses being multiplied anymore, we can just write plus x minus 30. And we can simplify this further. 30 minus 30 basically they become 0, and so we get that f of g of x is equal to just x. Well, that came out very simple. Just x. Alright. What if we want to find g of f of x? Let's see what that comes out as. So g of f of x. First of all, what is f of x equal to? F of x is equal to 30 plus 80x. 30 plus 80x. And so this is my input function. My inner function, I mean. Here's my inner function here. This is f of x. And my outer function is g of x. So I'm taking this, let me use a different color here. I'm taking this highlighted in red, and since my outer function is g of x, I'm going to replace x with my inner function. So how is that going to look like? Well, it's going to look like this. It's going to be 30 plus 80x. That's my inner function. And then that replaces x, and then I write minus 30 divided by 80. Minus 30, the whole thing divided by 80. There we go. I just composed both functions. Can you see how I took 80 plus 30 plus 80x, and I just simply replaced x here? And that's what I got here. Now there's nothing outside of the parentheses to multiply or distribute, so I don't need the parentheses. It just basically helps you show that I replaced x with this. And now I can go ahead and simplify. 30 minus 30, well, that basically becomes 0, and so we have 80x divided by 80. Well, the 80 is simplified to just 1, and so we have just 1x, which is, we can just write as x. And take a look at this. is this a coincidence that f of g of x is equal to x and g of f of x is equal to x as well? No, it's not a coincidence, because in the very beginning I told you that these are inverses of each other. Going all the way back to here, we were given this function, c is equal to 30 plus 80a, and we got our second function by simply solving for a from the first function. And since they are inverses of each other, when we take the composition of the functions, they should always give you the variable that you start with. In this case, it's x. And so that leads us to the definition of what an inverse function is. Let me go back here. Did I show everything? Yep. Two functions f and g are inverse functions if and only if g of x is equal to x, which is what we got here. G of x, f of g of x is equal to x. Same thing for all x in the domain of g, and g of f of x is equal to x, which is what we got right here. G of f of x, which is equal to x, right there. For all x in the domain of f. The function notation f inverse denotes the inverse of a function f and is read f inverse. Item 6 showed that the domain of a function is the range of its inverse. Likewise, the range of a function is the domain of its inverse. To find the inverse of a function, algebraically interchange the x and y variables and then solve for y. The -1 superscript in the function notation f inverse is not an exponent, and f inverse does not equal 1 over f when referring to functions. So here's what we can do. Since we found that f of x is equal to 30 plus 80x, and we basically found g of x by solving for the first function for the variable, instead of calling it g of x, we can call it f inverse of x is equal to x minus 30 divided by 80. This notation right here tells you that this function is the inverse of the first function. So again, the way you pronounce this is f inverse, not f to the -1. I'll make sure I correct you whenever you say it incorrectly. F inverse of x. Okay. So let's do example A. Find the inverse of the function f of x is equal to 2x minus 4. First thing it asks you to do is replace f of x with y. It's a very simple step. Step 1, replace f of x with y. So we have y is equal to 2x minus 4. Step 1. Step 2, interchange x and y, the x and y variables. So that simply means that you're taking the x and y variables and you're switching them, interchanging them. So x is equal to 2y minus 4. Simple as that. Step 3, solve for y. Now the reason I have this is basically reverse PEMDAS, is you may need to remember to follow reverse PEMDAS in order to solve when you're solving for a variable. In this case we want to solve for y, and so it's always good to have this. First thing you want to do is look for addition or subtraction. Since we're subtracting 4, we want to take the opposite of subtracting 4, which is to add 4 on both sides. So you add 4 to both sides. So what we get here is x plus 4 is equal to 2y. Okay, we're very close to solving for y here. Do we have any more addition or subtraction on this side? Nope. Do we have any division or multiplication? Yes, we're multiplying 2 times y, so the opposite is to divide by 2. And what we get here is y is equal to x plus 4 divided by 2. We solve for y. Done. Step 3 is done. Step 4. Replace y with f inverse of x. And so this is going to give me my final answer. F inverse of x is equal to x plus 4 divided by 2. That's it. Notice how we started with f of x is equal to 2x minus 4. Since we went through the 4 steps, we replace f of x with f inverse of x, and then write the inverse function, which is x plus 4 divided by 2. Those are the 4 steps in order to find the inverse. I had you do this to get some more practice for finding inverse. Notice here we have the function g of x, and so when you're writing your final answer, you're not going to write f inverse of x is equal to, it's going to be g inverse of x is equal to. So just keep that in mind. Here you're using h inverse of x. It depends on what function you have that the inverse is going to look like. So this is how your final answer should look like for each of these: g inverse of x, h inverse of x, and j inverse of x. And I wanted to emphasize that number 14 in your homework, page 92. Wait, is this page 92? No, number 14 in page 92. I wanted you to work on that. A and D. Alright, so those are the 4 steps to finding an inverse function, and I had you do some practice on page 91. Alright, thank you for watching.